I'm recording this now. Okay, let's get started on these. Remember, we've completed basically chapter 4. I'm just reviewing. I'm going to be reviewing this week for the midterm. Don't forget that there is posted already on Blackboard. I haven't seen that anybody has made an attempt to do it. There's a posted on Blackboard, a midterm preview. Very important that you do this. First of all, it counts as a quiz. Second of all, it's a preparation for you to be able to figure out how to use the Blackboard account to take a test, because we've been doing everything on Delta Math until now. So now it's very important that you get some practice using Blackboard. Go to your Blackboard account, go to tests and quizzes on the side. It's one of the options that you're going to have. Click on it and you will see a test there. That is your practice midterm. You have 2 chances to do it. And I will count the better mark as your mark for the quiz. If you find that you need additional chances, you can just email me and I'll set you up so that you can even take it a 3rd or a 4th time. You can take it as many times really as you want. I set it up for 2 times, but you can take it as many times as you want, as long as you let me know what you want to do. The midterm itself is not yet posted on Blackboard. I haven't gotten it yet, but it will be posted and available from October 28th, after our Friday class, through the 31st, which is next Monday. You have to set aside an hour's time to do the test. You can do it anytime. I'm giving you a pretty broad range of times to pick. If you aren't going to be available for an hour or an hour and 15 minutes, in that time frame, let me know and I can set up a special time for you to take your midterm. The midterm covers chapters 1 through 4, which ends with what the topic that we're just doing now, which is called solving quadratic equations. Chapter 4 basically has been working with polynomials, specifically you being able to factor polynomials. And we're going to see that there are several uses for this ability to factor. One of them is solving quadratic equations. We know we have a quadratic equation when we have an x squared, or whatever our variable is, squared. There's an exponent, and we have to be able to deal with the exponent. And if you recall what we said, the first step is to get everything equal to 0. The second step is factor. And the third step is to take each of the factors individually and set each of those equal to 0 to find your final answer. Let's demonstrate it with this particular example. We have x squared minus 4x equals 45. The first thing is to get it equal to 0, which means I've got to get the 45 to the other side of the equation. I'm going to minus 45. And when I arrange my terms, I need them arranged so that I have an x squared, an x, and a number, what we call descending order. So this is going to end up being x squared minus 4x minus 45 equaling 0. Notice these can't be combined because they're not like terms. We put them separately. And now we factor. And since this is a trinomial, 3 terms, the way we factor it is first look if there's a common factor. something that goes into every single term, and there isn't. So then we try and break it up into our two parentheses. We take the first term, which is x squared, and break it up obviously into x and x. And we then go to the last term, and since the last term is negative, remember we're looking for numbers that are going to multiply to this last number, negative 45. Obviously, since it's negative, one was going to have to be positive, and one is going to be negative. And the numbers that we can think of that multiply to 45, there are a few of them. We could do 1 and 45, 3 and 15, 4 and now I'm sorry, not 4. 5 and 9, those are all numbers that multiply to 45. But in this case, we wanted to multiply to 45, and since this is a minus, to subtract to 4. And that obviously has to be the 5 and the 9. And we want it to be to combine to a negative 4, which means the larger number is going to have to be the negative. So the 9 is going to go with a negative, and the 5 is going to go with a positive. You can always check by doing FOIL back. X times x would give you x squared. Outer would give you negative 9x, and inner would give you positive 5x, and negative 9x plus 5x does give you that negative 4x. And last, positive 5 times negative 9 gives you the negative 45. So we have now factored it correctly. We now take each one separately and set it equal to 0. So we're going to have x plus 5 equals 0 as one small equation. We're taking the bigger equation and breaking them down into smaller equations. And x minus 9 equals 0 as our other small equation. I'm erasing this because we don't need it anymore. So solving each of these equations gives me x equals negative 5. And here I have to add 9. And x equals 9. So our two answers are negative 5 and positive 9. Be careful with your signs. Make sure that after you factor it and when you bring it to the other side, you make sure you change the signs. This was x plus 5 equals 0. So that's why the x equals negative 5. The second equation is also a quadratic equation. Again, how do I know? How do I know this is a quadratic equation? Notice there's only, rewrite this so it's a little easier to see. We have x squared minus 25 equals 0. Again, I know it's a quadratic equation. Again, it says sum, I know, and it has an equal sign. It's got to be an equation. And has an x squared. That makes it an equation, a quadratic equation. And the first thing we have to do is make sure it's equal to 0, which it is. So we're there. The second thing we want to do is factor. Now remember, when you're factoring binomials, this is not a trinomial, this is a binomial. You can factor it if the first is a perfect square, which it is, it's x times x. The second number has to be a perfect square, 25 is 5 times 5. And the sign in between them has to be a minus. This is called the difference of squares. We can then break it up into our two parentheses by putting x and x as a front, 5 and 5 as the second term. And in one, it has to be a plus, and the other, it has to be a minus. It has to be what we call conjugate binomials. The two binomials turn out to be identical, except one has a plus in it and the other one has a minus. And again, after we finish factoring, we take each of the parentheses separately and set them equal to 0. So I get x plus 5 equal to 0 and x minus 5 equal to 0. And bringing the 5 over to the side, this gives me x equals negative 5. And here I'm going to do plus 5. So this gives me x equals positive 5. So my two answers are negative 5 and 5. So basically, they both are the same idea. You see you have a quadratic equation, you get everything on one side of the equation, set it equal to 0. So everything's on one side, then factor and set each factor separately equal to 0. By factoring, you make it from a more complicated situation into two simpler situations. Did anybody have any questions about this? Okay. I want to continue on this, doing some more quadratic equations and some more factoring, and showing you how another way that factoring can be used. It's now, I have 8:40. We have until 10 o'clock, so we have an hour and 20 minutes. I am going to, what I'd like to do is until 9:20, I'd like to do basically new material. And then from 9:20 on, I'm going to stop and I'm going to go back and spend time reviewing different topics for the midterm. So that's what we're going to be doing this whole week. Part of the period is going to be for new material, part will be for review for the midterm. Okay. I would like to look at an example like this. So this is just a factory. Remember, we've just learned that if you want to solve a quadratic equation, you better know how to factor. What if I ask you to factor this particular example? 9x squared plus 15x plus 4. This is a trinomial. Remember, if you were here with us on Friday, we went through number 1. We talked about the different types of factoring that one could have. And the first type of factoring that we always look for is something called the greatest common factor, GCF. Any type of factoring you're going to do, the first step is to see if there is what we call a greatest common factor. After you've taken care of that, there are three other types of factoring depending on whether you have 2, 3, or 4 terms. So we're going to first talk about, see if there's a greatest common factor. And then since this has 3 terms, we're going to talk about how to factor this for this trinomial. Now, if I remember how you find a common factor, you first look at the numbers, the coefficients. So this is 9, 15, and 4. Since there are 3 terms, the common factor would have to go into all 3 terms. There isn't any number. In terms of the variable, this is an x squared, this is an x, but this has no variable. So there is no common factor in this example. So now we go back to the fact that we're dealing with a trinomial and we want to try and factor the trinomial. And remember, when we're going to factor the trinomial, we're going to break it up into 2 parentheses. And what's different about this than what we were doing the other day is the fact that the leading coefficient, the number in front of the x squared, is not 1. It's not just a plain x squared. Because if it's just plain x squared, it's easy to start x and x. But if you have 9x squared, how do you start? Do you do 3x and 3x? Do you do x and 9x? There are a lot of different things. So what we do is a different method. This method is called the AC method. Now, this is called the AC method because what we're looking at is we're looking at multiplying the first number times the last number. This is called the A. When you're looking at a quadratic expression, it's ax squared plus bx plus c. So when you're looking at the AC method, what you're doing is you're multiplying the 9 times the 4, which is going to give you 36. I want to make sure I'm doing this right for you. Okay. So what do? We take this 9 times 4, which is 36. It actually happens to be positive 36. And we look for 2 numbers not that are multiplying to the 4, which is what we were doing before, to the last number. We're looking for 2 numbers that are going to multiply to 36. Now, since this is positive, to get a positive answer, either both numbers have to be positive or both numbers have to be negative. So I look at this middle term, since they're both, this number is positive, it must be that we're looking for 2 numbers, 2 positive numbers that are going to multiply to 36. But what they're going to do is, this is positive, so they have to add to 15. Can we think of 2 numbers that multiply to 36 and add to 15? Well, let's look at the numbers that we know that multiply to 36. There's 1 times 36. There's 2 times 18. There's 3 times 12. There's 4 times 9. There's 6 times 6. There are a lot of numbers, the combination of numbers that multiply to 36. But remember, not only are we, since this is positive, not only are we looking for numbers that multiply to 36, but we're also that's where this 15 comes up. We're looking for numbers that add to 15. This adds to 37. This adds to 20. The 3 plus 12 add to 15. 4 and 9 is 13, 6 and 6 is 12. The only combination that multiplies to the 36 and adds to the 15 is 3 and 12. So we write down separately the 3 and the 12. And after each of them, we put in X. We have taken this 15X and broken it down to 3X and 12X. You notice that 3X plus 12X does equal 15X. And I rewrite, I'm going to erase this because I just need the space. And we rewrite our original trinomial, which is 3 terms, into something that involves 4 terms. We bring down the 9x squared. We bring down the 4. Notice, not the 36. Let me just put the 36 over here because that's just to remind us that was the AC. We go back. The only thing we needed this 36 for was to make sure we're breaking up the middle term into the proper 2 terms. Now, since we now have 4 terms, we can use the grouping method. Remember the grouping method that we used the other day? When we have 4 terms, what we do is we use the grouping method. We group our 4 terms into 2 terms and 2 terms, and separately look for common factors in each group. So in the first group, the 9x squared plus 3x, we have a common factor of, well, between 9 and 3 is 3, and x squared and x is x. There's a common factor of 3x. Factoring out the 3x into 9x gives me 3x, and 3x into 3x gives me 1. So the first group factors into 3x and 3x plus 1. The second group, if I have of 12x and 4, has a common factor of 4. Now, in your second group, you always have to start it with either a plus or minus because you want it to be you don't want it just separate from here. So you want either, and obviously you're going to start, this whole thing is positive. So you're going to start with a positive 4, and 4 into 12x gives us 3x, and 4 into 1 gives us 1. And as you notice, we now have a common binomial factor of 3x plus 1. So we put that 3x plus 1 first. And in the second parentheses, we put the things that are outside the parentheses, the 3x plus 4. And we have now factored our originally example, 9x squared plus 15x plus 4, into the 2 binomials, 3x plus 1 and 3x plus 4. Again, if you want to make sure that you've done it correctly, you could do FOIL on these 2 binomials, and you would see 3x times 3x would give you the 9x squared. Outer would be 3x times 4, which is 12x, and 1 times 3x is 3x, and 12x plus 3x gives you 15x. And 1 times 4 is 4. So this is the correct factorization of the original example. This is the harder type of factoring to do because we have a leading coefficient. I'm going to do another example go through all the steps again, and then I'm going to show you, I'm going to do at least probably 2 more examples, and then I'll give you some to try. Okay, can I erase this now? Okay, so let's try this together. Okay, remember, this is just factoring. We're going to use it in solving quadratic equations in a few minutes, but first let's just do factoring. Let's try this. 6x squared minus 5x minus 6. What if I want to factor this trinomial? And as I did before, my first thing is to start and see if I can find a common factor, a GCF. Well, this is 6, 5, and 6. Remember, when we're looking for a common factor, it has to be a common factor of all the terms. Even though there's 6 here and 6 here, this 5 is not allowing us to find a common factor. Remember, in terms of the letters, this doesn't even have an X. So we're back at that same situation where we have a trinomial where the leading coefficient, what we're starting off with, is not just a plain X squared. It's a number in front of the X squared. In this case, it's 6x squared. So in this case, we have to use the AC method. And we do it, here's our A, and here's our C. We multiply the very first number times the very last number, and we get negative 36. Okay? Remember, we're only using this to somehow break up this middle number into 2 pieces so that we can use the grouping method. Now, since this is negative, it means one of the numbers is going to have to be positive, and one of the numbers is going to have to be negative, because the only way you can multiply and get a negative number is if one is positive and one is negative. And therefore, we're looking for, again, it happens to be this 36 again, we're looking for numbers that multiply to 36, but in this case, since this is minus, they have to subtract to 5. As a matter of fact, they have to subtract to negative 5, but we can deal with, let's just worry about the number. So again, let's put down that list of numbers that multiply to 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. And again, since this is minus, instead of looking for numbers that add to this middle number, we're now looking for numbers that subtract. What number is over here? What pair of numbers subtracts to 5? And obviously it's the 4 and the 9, because 9 minus 4 will give us 5. But basically, since this is a negative 5, we're going to have a negative 9 and a positive 4. Remember, the middle sign tells you what is the sign of the larger number. So now we're rewriting this original trinomial as 6x squared plus 4x. We have to put x's next to there because this is what we're breaking up. Minus 9x minus 6. And again, here we have, we've taken this trinomial and made it into 4 terms so we can use the grouping method. Remember, we're going to split it right here at the 2 and 2. So in the first group, we have 6x squared plus 4x. So between 6 and 4, the common factor is 2. And between x squared and x, of course, the common factor is x. So we're going to have a 2x on the outside. 2 into 6 is 3. X into x squared is x. And 2 into 4 is 2, and the x's cancel. So this 6x squared plus 4x, the first 2 terms, factor into 2x on the outside, 3x plus 2 on the inside. Now we go to our second group. Our second group is negative 9x minus 6. Now remember what I told you on your second group, we either have to start with a plus or a minus. You can't just start with a number because it has to be able to be connected to the first group. And you always pick the sign of the first number that you see. Since this number is a negative 9, I'm going to use as my common factor a negative. Now, between 9 and 6, the common factor is 3. So I'm going to make this negative 3. Again, always pick as your sign that you're going to attach this with to the second group, the sign that your first number of that group has. If this is minus, this will become a minus. If this is plus, this is a plus. Now we divide. This is our common factor, negative 3. So negative 3 into negative 9x is positive 3x. Negative 3 into negative 6, the negative into negative cancels, is positive 2. And again, we see now we had a common binomial factor of 3x plus 2. That's what goes in front. And our second factor becomes whatever on the outside, which is the 2x minus 3. Notice that's why you need a sign here, because you need something to attach it. And this is your answer. This is your factoring to your common factor, your trinomial that we were dealing with here. Okay. Let's do one more, and then I'll give you one to try. And I'm going to do one more with you, then I'll give you one to try. And then while you're trying one, I will then take attendance. Okay, this happens to be a quadratic equation. This is a solve. Suppose I give you 2x squared minus 11x equals negative 2. And I ask you to solve this quadratic equation. Okay, it's a quadratic equation because it has an x squared in it. Okay, again, when we have a quadratic equation, the first thing we want to do is get everything equal to 0. So I have to bring this 12 to the other side. Again, I know it's a quadratic equation because I have this x squared. Even if something equals 0, it might not be a quadratic equation. You have to have an x square in it. You have to have it. Whatever your variable in, it has to be squared. So this is going to give us 2x squared minus 11x plus 12 equal to 0. So here's our trinomial. And again, if you look at it, there is no common factor because the 2 doesn't go into every term. So we're going to want to factor this because we have to break it up into our 2 parentheses so that we can set each of the parentheses equal to 0 to make them take the big complicated equation into 2 smaller ones. But we're going to have to use the AC method because we're starting out with a number in front of the x squared. Now, what is our AC in this case? Well, it's a positive 2 times a positive 12 is a positive 24. Now, I could just write 24, but I like to include the plus or the minus to keep in mind as to what I should be doing to find the second numbers. So now I'm looking for two numbers that multiply to 24, and since this is plus, adds to 11. And we're going to see why it has to add to negative 11. Remember, in this case, since this is a negative, means we're going to have two negative numbers. Well, what numbers multiply to 24? 1 times 24, 2 times 12, 3 times 8, 4 times 6. I think that's it. All this combination, this is plus, so which numbers add to 11? Obviously, it's the 8 and 3. So I'm going to have a 3 and an 8. And since this was positive, both sides are going to have to be negative. The same, this being minus, they're both going to have to be negative. In other words, a negative 3 and a negative 8 will combine to negative 11. And negative 3 times negative 8 will give us the positive 24. Okay, so the plus is telling us that both signs are the same. The middle sign being negative means they're both negative, and that the numbers are going to add instead of subtract to that middle number. So writing down the rest of this, I bring down the 2x squared. I put x's next to each of these. I bring down the 12. I've broken up the trinomial 2x squared minus 11x plus 12 to 4 terms, 2x squared minus 3x minus 8x plus 12. If you would have combined these two, you go back to that. But we want it as 4 terms so we can use the grouping method. In our first group, we have 2x squared minus 3x with a common factor of x. So this gives us x times 2x minus 3. In my second group, I have negative 8x plus 12. My second group starts with a negative, so part of the common factor has to be negative. And 8 and 12 will give us 4. So our common factor is negative 4. Negative 4 into negative 8x gives me 2x. Negative 4 into positive 12 gives me negative 3. And there I see that my 2x minus 3 is that common factor. And the other thing that's out, the other factor is whatever's on the outside, which is x minus 4. This is what's equal to 0 now. We've taken this more complicated trinomial, broken it up into 2 binomials so that I can set each of these equal to 0. So 2x minus 3 equals 0 will give us one answer. X minus 4 equals 0 will give us another answer. Remember, when it says solve and it has an equal sign in the example, doesn't just say factor, but it says solve, you don't stop where you finish factoring. You have to go until you get the x equals separately. So here I'm going to do plus 3 on both sides, which will give us 2x equals 3. And that gives me 3x equals 3 halves as one answer. And here I'm going to do plus 4. And this will give me x equals 4. So here are my two answers, 3 halves, 3 over 2. Doesn't have to be in this braces, I just putting it there, but this is your answer. Obviously, it involves quite a bit of work. You really have to know how to factor. But remember, when you're doing a quadratic equation, you don't stop at the factoring. After you finish factoring, you have to go a couple steps more to get the x's separately. Okay. So I'm gonna now put a problem on the board for you to try. It's a quadratic equation, and I want you to solve this quadratic equation. Here's a problem for you. It's 3y squared. Instead of having an x, we're having a y, plus 11y equals 4. Solve this equation while I take attendance. Olivia, Isis,
Good morning.
good morning. How are you? Lewis Hart, Kaola. Emma,
I'm here.
hi, good morning.
Morning.
Demetrius,
Good morning.
good morning. Desmond. Shania. Shania,
Good morning.
hi, good morning. Caden. Kayla,
Yeah.
good morning. Sanjita. Sanjita. Oriana. Tahira.
I'm here.
Yeah, I know you're here. Just gonna say. Michaela. Kiana,
Here.
good morning.
Good morning.
Carleaf. Good morning. Jenna,
Good morning.
good morning. Tatiana,
Here.
good morning. Naya, I know you're here.
Good morning.
Good morning. Kazandu. Kazandu Small. Trainer. Thomas, Jean Thomas. Okay. So that's that. Okay, so let's continue with this example. We see it's a quadratic equation because it has a square in it. The variable has an exponent of 2, which means the first thing we've got to do is get it equal to 0. So I'm going to bring this 4 to the other side, which will give me 3y squared plus 11y minus 4 equals 0. And I'm sure you notice there is no common factor because there's 3, 11, and 4. Nothing goes into it, all 3 of them, and there's not a letter in all the terms. So this is another case of where we have to factor, but we have a leading coefficient. We have a number of 3 in front of the square term. So we're going to use our AC method. We're going to multiply the 3 times the negative 4. It's going to give us negative 12. And now we're going to look for 2 numbers that multiply to negative 12, which means one's going to have to be positive and one's going to have to be negative. And when we subtract those 2 numbers, we're going to get 11. Remember, we always go back to this. And obviously, the only numbers that I know that multiply to 12 are 1 times 12, 2 times 6, and 3 times 4. And the ones that subtract to 11 are obviously the 12 and 1. Now, since this is a positive, remember, I always use this to tell me whether I'm adding or subtracting those 2 numbers together. Since the larger number, since the middle number is positive, it's a positive 11, the larger number, the 12, is going to have to be the positive, and the smaller number is going to have to be the negative. Notice we now rewrite everything, 3y squared, put y's next to each of these, so that we have converted this trinomial into 4 terms. Notice it's really saying exactly the same thing. It's still the 3y squared. We have 12y minus 1y, which together give us 11y. we have -4. All we've done is taken that middle term and breaking it up into its original two pieces so that we can now factor it using grouping. In my first group, I have a 3y, that's a common factor. So I'm getting 3y times y plus 4. In my second group, there's no common factor except there's a minus here. And remember, when we start with minus, the common factor includes the minus. So this will be a -1 or just a minus. And this will give me y, and -1 into -4 is +4. So now we can take the y plus 4, our common factor, in one parentheses. Our other parentheses are the things that are on the outside, the 3y minus 1, and this equals 0. So that we now come to the point where we have our two smaller equations. The y plus 4 equaling 0, we split this up. And the 3y minus 1 equaling 0. Now this one, when I solve it, I bring the 4 to the other side, gives me y equals -4. This one, I have to add 1 to both sides to get the y's alone, so I get 3y equals 1. And then, but don't forget to divide by the 3. So my two answers are -4 and 1/3. Okay, and that's how we would have solved this quadratic equation. Just going one step further, starting chapter 5. I'm gonna spend about 10 minutes going on to chapter 5, and then we'll go on back for review. Does anybody have any questions before? Can I erase this now? Okay. Chapter 5 is a chapter on fractions. Except the type of fractions we're going to see are not just regular number fractions. They're what we call rational fractions. The word rational comes, its root is ratio, and a ratio is a fraction. A rational expression is a fraction that specifically is an algebraic fraction. It has letters in it, not just numbers. And we're going to go through this chapter and see how we do all the things that we did with regular fractions. What are the things that we learned how to do with fractions when we were back in elementary school? First of all, we did something that was called simplify, reduce fractions, or simplify the fractions. Then we did all the regular operations that we do on numbers, we did on fractions. You added, you subtracted, you multiplied, and divided. I want to today just concentrate on reducing fractions or simplifying fractions. Let's first look at a fraction that doesn't have any letters in it, just has numbers. And remember how we reduce those fractions, and then we'll go on to how we reduce fractions that do have variables in them. For example, if I gave you the fraction 6/8, and I said, reduce this fraction or simplify the fraction. What you're trying to do is looking for some number that will go evenly into both the numerator and the denominator. Or another way of saying that, we're looking for a common factor of both the numerator and the denominator. If you notice, I'm going to write it out, but you don't have to do this. You really could have written this as the 6 as 3 times 2, and the 8 as 4 times 2, and you'd see there's a common factor of 2 in both the numerator and the denominator. So you can cancel out that common factor, and your fraction reduces to 3/4. I'm sure you remember doing this. You probably just did it by saying, oh, I can divide the top and the bottom by 2, and that'll give me 3/4. Fractions are different than regular numbers in terms of that they're always different possibilities of the way the fraction could be written. In other words, 6/8 is exactly the same in value as 3/4. So in order to be able to compare answers to see if we both got the same answers, we're going to try and write our answers in simplest form so that the answers come out to be the same. So that's one of the things we're always going to be trying to look for. So the question is, what happens when we have not just numbers, but we have letters as well in our fraction? So if I have something like this, suppose I had 10 x squared y over 15 x y 4. Let's say I have a fraction that looks like this. Notice both the numerator and the denominator are what we call monomials. This is a single term, this is the single term. When we're dealing with monomials, what we do is we do things piece by piece. We look at the coefficients, the numbers. What can I reduce the 10 and the 15? What is the common factor of 10 and 15? Obviously, that's 5. 5 divides evenly into both 10 and 15. So divide the 10 by 5 and we'll get 2. Divide the 15 by 5 and we'll get 3. That takes care of the coefficients. How do we deal with the letter parts? Really very easily. To find the common factor of the letter, all we have to do is look for the lower exponent. Here I have an x squared. Here I have a plain x, which is really x to the 1. The one that'll go into both of them is the x to the 1, the lower exponent. And remember, when we're dividing letters, what we do is we're subtracting the exponents. So I'm going to put the ones in here just to remind us. You don't have to do that, but I just want you to remember that if you have a plain letter, its exponent is really 1. So we're going to cancel out, cross out the common factors. So the x to the 1 is going to get canceled out. And remember, we're going to subtract the larger exponent minus the smaller. 2 minus 1 is 1. And that leaves me x to the 1. Notice where it leaves it. Since the original larger exponent was on the top, that's where my letter ends up. Looking at the y's, there's a y, a plain y, which is y to the 1, and a y to the 4th. The common factor is y. We cancel out the lower exponent, which is the y to the 1, and we do 4 minus 1, which is 3, and we get y to the 3. Notice the y to the 3 is now in the bottom because that's where the larger exponent was. Now, you have to do this pretty neatly because if you notice, there's a lot of crossing out. We have to now see what we're left with after we cross everything out. So on top, we have a 2 and an x, so that's 2x. And in the bottom, we have a 3 and a y third. So my final answer, my simplified answer is 2x over 3y to the 3rd. I'm going to give you one to try, and then we're going to go do some review. A fourth b squared over 18 a squared b to the 7th. See if you could reduce this rational expression. Okay, let's work on this. Again, these are monomials. There's no pluses or minuses in between the letters. So we just do each thing piece by piece. The 8 and the 18. What goes into both 8 and 18? I think everybody will realize it's 2. The 8 divided by 2 will give us 4. The 18 divided by 2 will give us 9. Now we work on the a's. There's an a fourth and an a squared. The lower exponent is one we're going to cancel out, is the a squared. 4 minus 2 is 2. So we're going to be left with an a squared on top because that's where the larger exponent is. The b squared and the b7th, again, we're going to cancel out or cross out the one with the lower exponent, which is the b squared. And we're going to do 7 minus 2 is 5. And we're going to get b to the 5th in the bottom because that's where the larger b exponent is. So if I look at what I'm left with, on my numerator, I have a 4a squared. And on my denominator, I have 9b to the 5th. And that's my answer in simplest form, reducing that fraction. Okay, so let's stop right here with, I know it's just did a taste of what we're going to be doing in chapter 5, which is working with fractions. We're now going to spend the rest of the period, it's about 25 minutes, doing review for the midterm. Again, I'm going to remind you, posted on Blackboard, and I'd like to see some people working on it already because it has to be completed by the end of this week, is the midterm review. You must do the midterm review. It is considered a quiz for the course. It's one of the marks that you must get a mark for. You're getting 2 chances to do that midterm review. It'll prepare you for the way the midterm is going to be presented. Again, it is not on Delta Math. It is on Blackboard, and it's in the section called Tests and Quizzes. Starting on Friday, October 28th after class, through the 31st, I will post the midterm itself, which will be in its own section called midterm. So you won't have any problem finding it. And again, that has to be completed by the 31st of October, which is next Monday. As a review, we're going to start going through some examples. I'm first doing examples from chapter 1. Now, chapter 1 was the chapter in which we had fractions. We had equations, inequalities, absolute value equations, and some perimeter problems. So I'm going to try and do one of each type. First of all, let's talk about just solving a regular equation. Let's do one that has some fractions and some decimals in it. Let's say I have negative 7.2x plus 2.8 equaling 24.2 minus 2.2x. See, I'm going to give you a minute to solve them. Hello? I'm teaching. I'll call you. I'll call you. Okay, see if you can solve this equation. This is not a quadratic equation, doesn't have an x squared. It's just a regular linear equation. It does have decimals. You can make these decimals bigger so you can see them. And if you get an answer, you can post it on the chat. This is an example that it's a good idea to take out your calculator for, because the numbers are not such simple numbers to work with. So this is one in which you really want to be able to use a calculator. Okay, let's work on this together. Whenever we want to solve a regular equation, we want to always bring the x's to the left and the numbers to the right. So the first thing I'm going to do is I'm going to add plus 2.2x to both sides. Now, I'm going to take out my calculator, and on my calculator, I'm putting on negative 7.2. I'm not putting in the x's because I just want to add the numbers in front, the coefficient. Plus 2.2, which gives me negative 5. So this is negative 5x plus 2.8 equals 24.2. This is canceled out. Now I have to bring this 2.8 to the other side. So I'm going to subtract 2.8, which will give me negative 5x. Okay, again, I'm using my calculator. I'm doing 24.2 minus 2.8, which is giving me 21.4. And now I have to divide by -5. Because in front, I divide by the coefficient of the x, so I'm gonna divide this by -5 as well. So I have 21.4 divided by -5, which gives me -4.28. And that's the answer you should have gotten. I hope some people did get that answer. That is, again, if there would have been a parentheses, we would have first removed the parentheses using distributive property. So this is solving linear equations. There'll be 1 or 2 questions on the midterm on that topic. Okay, let's go to the next type of example. We learned how to solve an inequality. Suppose I gave you an inequality that looks like this. 2 times x minus 2 is less than 4 times x plus 3. And I want you to write the solution in interval notation. Okay, I'm going to give you a couple minutes to try this one. Okay, let's see. Now I came up with an answer. Let's see if we come up with the same answer. We're going to first remove the parentheses, so we'll get 2x minus 4 less than 4x plus 12. And remember, with an inequality, I always want to end up with the x's on the left side. So I'm going to bring this 4x to the other side. And 2x minus 4x will give me negative 2x minus 4 is less than 12. Gone. And then I'll add 4 to both sides to get rid of this negative 4. So I'll get negative 2x is less than 16. And now I have to divide everything by negative 2. Don't forget, when you're dividing by a negative number, the direction of the inequality switches so that this ends up being x greater than negative 8 as our answer in inequality form. This on the number line would look like this. Here's the 0. See, this is negative 8. So it would have to be an open circle because it's just a greater than, and the arrow has to point to the right, which means that we have parentheses, negative 8, comma, infinity, parentheses. Which is perfect. Ayana, Naya. Okay, so Naya, I'm going to give you an extra credit here. Answer my question. You. Okay. Let's remind ourselves also, we could have something called a double inequality or a compound inequality, something that looks like this. Where you have two less than signs in it. It's called a compound inequality. I'm going to give you a minute to try and solve that compound inequality. Okay, let's work on this. If you recall, when you had this kind of double inequality, what you're concentrating is trying to get the x alone in the middle. So the first thing I want to do is get rid of this -6. So I'm going to add 6. But remember, you're really doing two columns at the same time. So not only are you adding the 6 at the right end, you're also adding it at the left end. You're doing it at both the ends. Whatever you do at the middle, you do at both ends. So here you're going to do 9 plus 6, which will give you 15. This will stay 3x. This is canceled. And this is not 15 plus 6, which is 21. Then again, you go back to the middle. You want to get the x alone, so you're going to have to divide by 3. So at either end, you're going to divide by 3, which will give you 5 less than x less than 7. This is your answer as an inequality. On the number line, here's your number line. Here's 1, 2, 3, 4, 5, 7. Here's 5. There's an open circle there because it's just a plane. Sorry, 7, an open circle there, and you connect the 2. It's everything in between the 5 and the 7. In other words, it's 5 parentheses because it's less than, it's not a less than or equal to, comma 7 parentheses. Remember, you use the brackets, the square parentheses, if it's less than or less, if it has a less than or equal sign, if it has its little extra line over here. I just want to do one more problem. I'm not going to even give you time to do it. I'm going to do it together with you. We're going to talk about how to solve an absolute value equation. Don't forget, when you have an absolute value equation, suppose you have something like this. The absolute value of 2x minus 9 less than 5 equals 10. And you're asked to solve this absolute. Remember, these two signs are the absolute value signs. You first have to get the absolute value by itself. So you're going to add 5 to both sides. That'll give you the absolute value of 2x minus 9 equals 15. Because 10 plus 5 is 15. Make sure you look at this number on the other side. After you have the absolute value by itself, it has to be positive. If this is a negative number, you stop right there. It's impossible to solve. There is no solution. But when it's positive, you go further by breaking it up into two equations. 2x minus 9 equals 15 is one equation. 2x minus 9 equals negative 15 is your other equation. When you get this as a multiple choice question, you can immediately eliminate the answers that only give you one solution, because with an absolute value equation, just like a quadratic equation, you're supposed to get two solutions. Here you're going to do plus 9 to both sides. So this will give you 2x equals 24. So my answer is 12. And here you're going to do again plus 9. You do the same thing on both of them. But here you're getting 2x equals negative 15 plus 9, which is negative 3. So your other answer is negative 3. And you must put down both solutions, negative 3 and 12. An absolute value equation gets two answers. Either it doesn't have any solutions, rarely does it come up with just one solution. But that's only if this would be equal to 0, and that never happens. Okay, we're gonna leave it right here. Have a good day. We'll continue our new material and our review on Wednesday. Any questions? Okay, have a good day. Thank you.
Have a good day, Professor.
Bye-bye. Have a great day.